Morning, everyone. Really excited to be back in person with other technologists. My office has started to feel a little lonely. I don't know about yours. Anyway, he talked about hypergrowth. It's a buzzword, but I've been able to do it a few times in my career, so I've accepted the word at this point. So how do you empower that? First, I'll tell you a little bit about who I am. Worked in cannabis technology. I'm now in Mac device management. Worked in hosting, a lot of different places, and worked at a lot of places where they wanted to go from the go-to-market phase to the enterprise phase, and they wanted to do it very quickly. I'm currently the director of engineering at Kandji. What's Kandji? I'm contractually required to say this by my company. We're Apple device management and security platform, so if your IT team wants to securely deploy a whole bunch of macOS or iOS devices, we can help you do that. When we say hypergrowth, what does that mean? I was employee 134 in August. We're 325, looking at over 400 by the end of this year. So a lot of growing. I thought you were required to have a pompous quote for every presentation. So this is mine. Experience is the hardest kind of teacher, gives you the test first and gives you a lesson afterwards. That's Oscar Wilde. I also don't want to stand up here and act like I haven't made a bunch of mistakes. We just talked about Docker Swarm a little bit. In 2017, I made the choice to use Rancher Cattle. Have you ever heard of it? No, because Kubernetes won. Few head nods, but hope you didn't go through what I went through, migrating 25 services off of it. That little B represents an internal service we built to handle deployments and to put secrets into the environment. We thought we were really clever at the time, but then we have to onboard new people to it all the time. People make feature requests all the time. So when we made the shift past that, we opted to go open source. GitOps platform called Argo that I'll talk about in a little bit. And then the error message there is just to point out, I'm not pretending that we've followed this path and we do a perfect job. Last Thursday, I was supposed to meet with Datadog for a dry run. We had a production incident during that time, so we had to delay it. So anyway, what do you want to do before you start? I think there's 3 steps that I usually try to take things through because what I really want to do is empower self-service, but I want to do it in a consistent way. So these are the 3 steps I start with. Order of operations, define with the team. Yours could be different. I do think it's important to have it. It's not just how we make our decisions. It's publicly available to every team that we work with. So if you want to know why we make the choices that we make, you can look through our order of operations and you can understand how we think about things. You'll see reliabilities first here. That's because I have an amazing security team who owns a lot of the security. Security is first for them. Reliability is first for us. We work together. It's a beautiful, harmonious relationship. But also, I wanted to point out here that I'm talking about self-service a lot, but to do that, you have to put these building blocks in place. So this is our order of operations. Step 2 is firefighting. Almost every company I've gone to work for, when we wanted to grow, we were stuck, specifically the infrastructure SRE teams were stuck in this loop of firefighting. Developers always need help. They need access to something. They need you to do something they don't have access to. And so you're constantly helping them do that and fighting production issues. I like to address that a few ways. Define a path for interrupt work. We basically call that toil work and we give it to our on-call. So we just subtract a person from all of our roadmap work as we're going forward, all this empowerment that we're going to be talking about. Create shared ownership of alerts. I don't think I have to convince anyone in here, but a lot of times development doesn't want to take ownership of the pager. That is one of the most important conversations that you will have, and you have to spread that ownership across the company, not just for code, but for alerts. When I started at Kandji, the infrastructure team was being paged 14 times a week. We're down less than 1. Part of that is because we made developers own their own alerts, and then we work to make improvements otherwise. And then the last one is clearly define incident process. If your incident process is someone pings you individually in Slack, that's not an incident process at all. Please define one, write it down, make sure everyone reads it, show it to the C-suite so they won't bother you about it. And then the last step is defining principles. These are 4 of ours. We have 6. I build them with the teams. As I started a new place, I always have a starting place. But again, published in Confluence for everyone in the company to read. This is how we make decisions. This is why sometimes we say no to your great idea, and then we come back with a better idea, at least we think is better. And so we have these principles here. CI/CD for everything. That includes the infrastructure team. We push nothing to production that doesn't go through CI/CD. Production is read-only except for break glass. Again, even for the infrastructure and SRE teams, we need consistent state in our infrastructure if we're gonna grow in the way that we need to, and allowing people to make modifications by hand doesn't get you there. I think simpler is better is maybe the most important one. Service-oriented architectures are incredibly complicated anyway. So at every turn, when you're having a discussion in the same way that cost comes up from your boss, simplicity comes up from my team. Do we need that extra Nginx proxy in there? Is that gonna make it harder to explain to the next person? And then immutable infrastructure, which if you're doing everything through code, you're not adjusting anything in production, it's a very consistent interface for all the teams to work with. So what am I trying to build? Happy path, right? We create a clear and repeatable process for standardization. The name of your service is the name of your Git repo, is the name of your Kubernetes namespace, is the name of your folder, and our secrets tool called Vault. Just incredible consistency throughout. And we make it very easy for developers to follow the path that we've laid out, and we work with them to empower that path. The other reason I like the term happy path is it implies that there is an unhappy path. And that is not an impossible thing, but in the same way that you try to control features in an application, and you call it feature creep when you're adding things that isn't necessarily core to what you're doing, that's kind of the unhappy path here. We do open it up for development teams to, if they don't like Redis and they want to use another solution, that's totally available, but they take on some additional ownership. Again, our job is to support the entire company through growth, not one-off teams. So self-service improvements, there's a bunch here. I'm gonna zip through them because I realized my presentation was slightly too long. But a lot of these are empowered by tools from a company called HashiCorp I'm sure we're all familiar with. You'll see a bunch of those here. My favorite one, the one that's I think #1 building block, is infrastructure as code. So I mentioned immutable infrastructure as the initial one of our principles. We use Terraform to accomplish that. I'll show the repos in a second, but basically we create a standard mono repo that has our services and modules inside of it. Modules are used for repeatable actions. If somebody, I'm gonna use Redis as the example again, somebody wants a Redis, we have a module for Redis, you pass variables through, you call it from the service. That way every Redis that we have, since we're not changing anything by hand in production, is the same. We lay out our repo like this. It's a pattern I'm sure you have at least seen before. Module services, some shared items. S3 in the center is our module. You can see it's calling a few different services. And then we simply call that module in that Datadog S3 archive service. We pass the environments through YAML. It's actually very easy to follow. And the other thing that I really like about it is we open the repo up to all of our development teams. We use code owners to make sure that someone on the infrastructure team can review it before it goes out. But if you want to empower self-service, you give people the access to make the change themselves. A lot of developers don't care, but some really do, and why not open it up to them? How do we keep the state consistent? We wrote a simple diff checker. We put it in our make file. It runs every morning. This is not about blame. This is about accountability. When you want to go and work in infrastructure as code, the state of your infrastructure is in the code. If there's a mismatch, whoever's trying to make that change has to fight through the mismatch that someone else left them. So we do it all through code. We make sure it stays the same and it doesn't vary. That's step one. Step two, democratized deployments. When I started at Kandji, they used a custom Lambda written in Python to do deployments, and 3 people had access to it. They'd get on a call and they'd do deployments. That's obviously not empowering self-service, and that's not where you want to be if you seek to be a high deployment company. This speaks to our principle of CI/CD for everything. If you want everybody to use CI/CD for everything, then everyone needs access to CI/CD. It's pretty simple. So my first goal when I want to improve deployments and have this discussion is to start getting everyone thinking about building a container once and pushing it through environments. So when the container for that code is built in development, you can associate the SHA of the code to it, put it in your Docker repository. We like Harbor, but Docker Hub works great. And then that SHA of image can literally be pushed through the environment. So not only is the code guaranteed to be the same, but everything about the image is guaranteed to be the same through lower environments. It just so happened that this principle that we already had fits really well with a modern deployment technique called gitops. What are the 4 principles of GitOps? The entire system is described declaratively. What does that mean? Just so we're all on the same page. Declarative config defines the desired state of a system. That's Terraform, Kubernetes. Basically, the code understands what the entire system should be and can match against it, whereas imperative config is running a series of commands to get it where you want. So if you've ever looped together some AWS CLI and Bash, I know I have, that's just taking steps, but each step you run doesn't understand what happened before it or after it, doesn't understand what the state should be. So GitOps brings that declarative model to your deployments. So if you have everything in code for Terraform and that defines the underlying resources, then GitOps defines the deployments and it has it saved in Git. The system state, again, as I just said, is versioned in Git. Essentially, the SHA of what containers should be in an environment is stored in Git, gets pushed at the end of your CI/CD, so it's incredibly easy to roll back, roll forward, go back to last Tuesday. You can take the entire cluster back to the deployments last Tuesday if you desire that for some reason. But in general, it brings all the niceties of version control to deployments in a way where, it was largely imperative before. So I kind of ran through some of these, but the benefit of GitOps is the entire system is represented through version control. If I have a cluster here with 30 services deployed and I want to stand another one up, instead of running through 30 deployments to get them over there, I just point the agent at our Git repo, it syncs. I've had 30 services do that in less than 5 minutes, which lets us do things like blue-green clusters and some of these more advanced techniques that we want to get to. And then when you're in version control, you get all these great things that I think we're all familiar with. History of changes, approval workflow, disaster recovery, everything is stored in code right there. The other thing that GitOps does is it divides your CI/CD. Whatever tool you're using, Circle, CodeFresh, whatever it is, its job is only to build the container and push the container to your Docker Hub and update. You can either do a PR and update it by hand if you want, or we actually have something at the end of our builds that writes that SHA into Git. So, but the actual deployment is handled by a tool called Argo CD. There's a couple of these, but we really liked Argo for some of the added benefits. The core job of it is to sync everything. So it's our cluster bootstrap syncer. It syncs all of our application deployments. But the other nice thing Argo gives you is an add-on called Argo Rollouts, and that gives you canary deployments out of the box defined in YAML. So we open that up to our development team. They can set the metric for their canary. They can do it by hand. They can set the percentage. Everything open through Git for them allows us to do it, makes everything safe. We can roll it back pretty easily. So a lot of comfort there and a lot of self-service opened up for them. What's your next thing that people ping you about all the time, unless you've figured out a way for it, is I need to update this secret in production. You won't let me have access. How do I do that? We want to keep things simple. I'll say something. I've worked a few places where they put configuration in with secrets because they thought that was easier. I've found through the years that configuration should go in the app repo. It's much easier to understand. And then your secrets go into your secret manager. We like Vault. The nice thing about Vault is it has versioning of keys. So you can easily roll back and roll back to previous versions. It's from HashiCorp as well, and it's intended to secure, store, and control access to secrets. So we can open up Vault. We have a space in Vault that is open for developers for their service, and it's where they put keys like Mailgun and some of these external third-party keys, not like database passwords and things like that. But we open it up for them so they can easily add new secrets, edit the secrets. And then the other pain point that I'm sure we've all felt is how do you get your secrets into the container? I've seen Docker files with empty environment variables all the way down as you need it there for your secrets manager to inject it. We leverage a tool called Bonsai, the Bonsai Cloud Mutating Webhook. It automatically reads from a Vault namespace, and as I told you earlier, our Kubernetes namespace, Vault namespace is named the repo. They're all consistent. So any key that you add into Vault, you add it in Vault, all you have to do is roll the container, the key is there. So no PRs into the application development repo to add it to the Docker container, none of that painful part of the process. The other thing is we should not be the people troubleshooting every app in production. That should not be an infrastructure job. That needs to be shared. But how do you give people access to production and then understand what they did and be accountable in audits and things like that for what they may have done. Gone are the days there are jump boxes and whitelisting IPs, right? That again is a bottleneck for them. It's an unauditable process. We use Teleport. It's free, open source from Gravitational. It provides auditable access to the Kubernetes API. So you run a special command from Teleport, and then you're dropped into the Kubernetes API with your permissions based on RBAC. You can have access all the time. You can request access, but the nice thing is it gives you a printable file of everything they ran as well as a video. I don't know who watches the videos, but the videos are available if you want to watch someone hack around in production. We gave them consistent infrastructure with Terraform. We gave them access to deployments, largely with gitops. We made it easier for secrets. We made access to production easier. Observability, that's the next one. When I started at the company before this, that I'm at now, it's called Weedmaps. We had 5 different tools for observability. New Relic, Prometheus, Grafana, Datadog was in a POC, Lightstep, and Rigor for synthetic monitors. When you have 12 teams and 20 plus services, people move around from teams, and having to switch to a different observability tool was kind of a nightmare. It was also a nightmare from the infrastructure side, trying to help them troubleshoot. So we like Datadog. It builds all those things in together. I'm sorry, no surprise we like Datadog. It gives us everything in one package, synthetic monitors. It created, in Datadog, it's kind of the holy grail for me of observability. You can go RUM to tracing to logs to network and infrastructure metrics and monitoring. That kind of gives you the complete life cycle of a request. We also really like that our synthetic monitors were built in with our standard monitors. So that just makes everything easier. You onboard developers into one tool. The documentation for Datadog is great. Instead of writing custom documentation, I just have a list of links I share to people and say, read these in order, and then you're gonna be fine. They've got videos, etc. The other thing I like about Datadog is, I don't know how many of you reported to the C-suite, but you do a lot of making graphs in slides over and over and over again. So I want to get out of that business if I can. Datadog kind of helps us do that because you can actually simplify dashboards down to the point where you can get higher level people to look at it, or at least you can take a screenshot of that. One of the ways we do that is using the SLO tool. This is an example of it running on a single endpoint. At Kandji right now, every single service has our 3 main endpoints, SLOs in place for error rate and latency. Then we have a roll-up dashboard of just those simple little green, yellow, red boxes that Datadog makes and can let you know if you're doing a good or bad job. And that rolls up across all the services. We have a dashboard that just shows all of the SLO boxes, so they can at any time go back and take a look and say, oh, we're all green, and then they're happy, most of the time. So thank you, Datadog, for that. The last one, it's everybody's least favorite because as soon as you write documentation, it is out of date. I feel that pain as well, but it is also really important. I just stood up here and told you a lot about how we think it's important that the people that work with me understand that as well. One thing that we found is we used to not divide our internal and external documentation. So if it was Vault, part of it was about how you stand up and maintain Vault, and the next part was how a user should use it. We divide our documentation into internal and external documentation for the infrastructure team now. Internal is hidden from other teams, so it doesn't show up in search. So when they're looking for something about Vault, they don't end up in the wrong place. And then the last one here is the RFC process. That's a pretty standard process across a lot of open source. It's request for comment. Basically, if you're gonna make a big change, one we made recently was to change our branching strategy completely. And so this was written up and discussed across engineering. But I think the most important part about an RFC is it preserves why you made the decision, not just what decision you made and who talked about it, but why. Because 6 months from now, someone's going to ask you to defend that decision, and you may or may not remember it as well as you think you would. So to wrap it up, a lot of what I've said is pretty opinionated. You may not agree with a lot of it. I'd love to chat with you about it, about your experience. This is just a pattern that I've been able to put together and basically make a checklist as I want to go and improve things. I'm typically coming into companies that are smaller, looking to go bigger, and are needing to change process, technology, hire, and so I've found it really helpful to really define things and really have a strong belief system that we fall back on, and then share that with other people. I didn't build this by myself. I've worked with a lot of people that are very talented, although they do break production sometimes. So I just wanted to make sure to show their faces and give them a shout out because I've worked with some amazingly talented engineers. And the last thing I would say is let's talk. I'm here because I'm excited to be here because I want to talk to other people who are into technology. So I'm willing to talk about anything but Azure. Literally no one wants to talk about Azure, I promise. All right, and that's me. Thank you.